Chapter 12 deals with rational expressions and functions. We're going to start with Chapter 12 in Section 3, as you can see, is in our current calendar here. And as we look at our next couple days, we're going to be spending 2 weeks as we move through Chapter 12, and then we're going to wrap up on the Friday before our finals with our test. I do have built in here, you can see a couple days of review as we're trying to look through this. I want to make sure that you are comfortable and know that we've got a half day designated there on the 21st for review. Following our quiz, we're going to have another day of review there, and then we'll have a half day period of time review with our final packet coming up. But as we look at our first material, I think this says it very clearly with our peanuts comment here, is we're going to be dealing with fractions this chapter. And some of you may have good experience with fractions in the past, and some of you may have struggled a little bit, but we're going to kind of walk through it very slowly together and make sure that you're comfortable as we move through that material. So let's take a look at our first section. If you turn in your binders to your new section to page 3 or page 5, our first section is about simplifying rational expressions. And as we look at rational expressions, we can understand a rational expression is a fraction. And we have something in the numerator and something in the denominator. So each of these four cases, we're going to have different types of fractions. Here we have a quadratic trinomial in the denominator, and on the numerator we have a quadratic binomial. And so we might be able to factor those and simplify, but we're going to show you how to do that as we go through today. Our basic steps that we're going to be following is we're going to factor both the numerator and denominator first. Then we're going to cancel factors, and that's one of our more important ideas. We only cancel factors. We can't cancel things that are not factors, just factors. And we'll talk about what those are with examples. So let's look down here at our first example. We're going to simplify this. Now remember, the factors of 25, I could break this out in expanded form, and I could say that's 5 times 5 times a, divided by, and I'm going to write 30 as 5 times 6, times a, times a, times a. Now, as we're looking at that, we can say, okay, what are we able to cancel? Well, we can cancel the 2 5s, we can cancel the 2 a's. That's going to give us a final answer in the numerator of 5 and the denominator of 6a squared. And so that will be our answer, is 5 over 6a squared. Notice we only canceled things that were connected with multiplication. On our second problem, as we're looking at our second one, we're going to kind of walk through this. The numerator is one monomial, so I'm just going to rewrite that. But the denominator, I notice we have a GCF here, and that GCF is 2. And so I'm going to take that GCF out, and that's going to leave us with x plus 5 on the inside of our parentheses. Now, once again, we have the ability to cancel factors. A factor of 16 is 2, and so we're going to cancel the 2 and the 16 and get 1 and 8. That's going to leave us an answer on the top of 8x squared divided by x plus 5. Now, some of you are going to be obviously answering yourselves the question in your mind, what about the x squared on the top and the x plus 5 on the bottom? We cannot cancel the x on the bottom with the x squared on the top because the x on the bottom is connected to the 5 with a plus sign. So that is going to be our answer, just as it is, with no more canceling. Let's look down at number 3 and number 4. On number 3, our first question that we're going to have to analyze in most of these problems is, does the numerator factor? Can you think of a GCF that goes into the numerator? Well, in this case, I think that would be 6. So I'm going to take a 6 out, and I'm going to have x minus 6 left over. Now I look at the denominator. What's a GCF that goes into both 12 and 24? If you're thinking 12, you're on the right page. So 12 times x is 12x, and 12 times negative 2 is 24. Now I look to cancel. The 6 and the 12 will cancel to 1 and a 2. That's going to leave me with a response of x minus 6 on the top and 2 parentheses x minus 2 on the bottom. Once again, this is our final answer. The 6 on the top does not cancel with this 2 out front because the 6 on the top is connected with a minus sign in the middle. So that's our answer. X minus 6 over 2 parentheses, x minus 2 squared. So, let's look at our next one. As you've probably figured out by now, GCFs are a big part of simplifying and canceling. Can you think of what is the GCF here on the numerator? Hopefully you're thinking 3x. And so we're going to put that out front. I want to take a minute for a sec, and I want you to think about what would be left over on the inside. Take a minute and write down what's left. 3x times what is 3x squared minus 6x? When you think you have the answer, look up. I'm hoping that you also realized it's x minus 2 on the bottom. Now, our GCF on the bottom, as we look at our second part, both 6 and x are included in both part. Once again, what's left on the bottom is just an x and a positive 4. Now we go into our canceling phase. The 3 and the 6 cancel to a 1 and a 2. The x's cancel, and that's it. So we're left with x minus 2 over 2 parentheses x plus 4. So in each of these first 4 problems, we've had situations where we're talking about GCFs canceling with other things that are multiplied together. Let's flip the page and look at page 2. On page 2, we're faced with binomials on the top and a trinomial on the bottom. This quadratic trinomial on the bottom, hopefully by now you're realizing that's going to factor into 2 parentheses. But let's start with the easy one, which is the top. Notice I'm not putting an equal sign, but an arrow. What is the GCF of the top 2? That would be a 3. That leaves us with an x plus 4 on the top. Looking at the bottom, by now you're pretty good at factoring, and you know that it has to be x and x, and I want you to fill in your signs. Your 3 options are minus minus, plus minus, or plus plus. Fill in the one sign that you think would be appropriate based on the minus sign of the 20. Hopefully you're also going to say plus minus. My factors of 20, as you know, are 1 and 20, 2 and 10, 4 and 5. By now you're realizing, I'm sure, that your answers are going to be negative 5 and positive 4. We're going to check this with OI and realize that's 4x minus 5x is negative 1x, and that matches with our negative 1x that we have right up there. Now we go to the canceling stage, now that we've factored it. The x plus 4's cancel. That's going to take us to our final answer of 3 over x minus 5. Remember, the only thing that cancels is factors. Let's look at our next one. If I was going to take a look at this, I would start with the denominator, because I feel like the denominator is an easier problem to factor. I know the denominator has a GCF of 8, and that has an x plus 2 left inside. My numerator is a little unusual in that we have a 2 in front. So that means one of my factors is going to be 2x, the other is going to be x. Once again, we have 3 possibilities, plus plus, minus minus, and plus minus. In this case, it's going to be plus plus because we have a plus plus on our signs. Our possible factors are either 1 and 2 or 2 and 1. Hopefully you're realizing that you cannot have a 2 in the front because then there would be a GCF between those two. So the 2 must be in the back, a 1 in the front. Now let's check it with OI. Outside we have 4x, inside we have 1x. We add those together and get 5x. So the outside and the inside get us to 5x, and that is correct. We can now cancel the x plus 2's. What does that leave us with? 2x plus 1 over 8. A lot of you might be wanting to ask yourselves, can I cancel the 2 with the 8? You cannot, because the 2 is connected to the x plus 1, and you have to leave your answer just like that. Moving down to number 7, we have a familiar problem in the denominator of we have possible signs plus plus, minus minus, or plus minus. So let's take a look and see what we're going to have here. It's going to have to be x and x, plus and plus, because the back side is a plus, and then you look to the middle sign, and that also is a plus. Factors of 8, 1 and 8, 2 and 4. Which of those combine to 6x? 2 and 4. Now we look at the numerator. Do you recognize this as the difference of two squares? I hope so. That's x plus 4 and x minus 4. Those were called conjugates. And now you can see the x plus 4's cancel. That takes us to an x minus 4 over an x plus 2. And I can't emphasize enough that the 4 and the 2 do not cancel in this case. And that is going to be your answer. Now, I want to take you back up through our examples to remind you and kind of look for possible things. Notice how we have the x plus 2 and the x plus 2. My suggestion would be is to factor the easiest portion first, like a number 5. That would be the top. And then you could say, is it going to be likely that the x plus 4 might be a factor of the bottom as well? Use those indicators to help you solve the problems easier. Obviously on number 6 that was the case, and on number 7. So in each of these cases we've got to consider letting the problem give us clues to solving and making it easier on us. Okay? Now, I want to practice these 12 problems just for a little bit, and then we're going to come back together and look at some other ways to factor and simplify fractions. So let's start right now on 12.3a on page 654, 1 through 12.